in front of the heat transfer module located at the ME laboratory at Don Bosco Technical College. So how does the heat transfer module work? It is simple. The steam generator here releases steam. So the steam flows through these pipes and directly to the heat transfer module. So the heat transfer module pumps water to cool down the steam that it releases. In the heat transfer module, we install four instruments, 2 sensors and two controls. The first sensor is the temperature sensor. We installed DS18B20 for our temperature sensor, and the second sensor is the flow meter right here. And the other two controls is the quadrant, which controls the pump, and the servo motor, which automatically controls the quadrant.
In this part, I will enumerate the specs of flow sensor. This is the flow sensor. First is the working voltage, which is 5 to 18 volts DC. Second is the max current draw, which is 15 milliamperes at 5 volts. And working flow rate, which is 1 to 60 liters per minute. And working temperature range, which is negative 25 to 125 degrees Celsius. And the flow rate pulse characteristic, which is the equation frequency equals 7.5 times flow rate. In this part, I will enumerate the specs of the DS18 sensor, which is here, inside this one, inside the bulb. There. Oh. Here. First is the unique one wire that interface requires only one port pin for communication, which is the number 2. Pin number 2. Reduce component count with integrated temperature sensor. Measures from negative 55 degrees Celsius to 125 degrees Celsius. And the tolerance of negative 10 degrees Celsius to 85 degrees Celsius. Programmable resolution from 9 bits to 12 bits. No external components required. Simplifies distributed temperature sensing applications with multi-drop capability. Each device has a unique 64-bit serial code stored in onboard ROM. Flexible, user-definable, non-volatile alarm settings with alarm search. Command identifies devices with temperatures outside program limits. That's all. In this part, I will enumerate the specs of our quadrant. This is our quadrant. It is a Q6015 LTH with 600 volts and 15 amperes. That's all. In this part, I will enumerate the specs of our servo motor. This is the servo motor. Its dimensions is 38 by 11.5 by 24 millimeters. And its weight is 17 grams, not including the cable and connector. 18 grams if it is included, the cable and the connector. Its speed is 0.14 seconds per 60 degrees in 4.8 volts and 0.12 seconds per 60 degrees in 6.0 volts. Its torque is 2.5 Newton centimeter in 4.8 volts and 3 Newton centimeters in 6.0 volts. Its voltage capacity is 4.8 volts to 6.0 volts. The connector type JR type, yellow signal, red VCC, and brown is ground. That's all.
First, I'll explain the connections for the flow sensor and how it is connected. In here, it's the flow sensor connected to the Arduino. It is for the data. It's connected at pin 2 and connected at the 5 volts and the ground. Second is the connection for the temperature sensor DS18B20 and the servo motor. In here, this is the connection. For the DS18B20, it's connected at pin 2, and for the servo motor, it is connected at pin 9. Then for the power source of the DS18 is connected here at 5 volts in the ground. And for the power source of the servo motor, it is here for the separate power supply because it will use too much power for the Arduino. So here it is the servo motor, and for the flow control we use the quad rack, which is here connected to the power box and the circuit breaker here. The connections between the circuits are connected by the temperature sensor, which is the independent variable, and the dependent is the flow, which is the controlled by the quadra. Then when the temperature rises up to 80 degrees Celsius, before 80 degrees the servo motor will be partially open, but when the temperature rises beyond 80 degrees Celsius, it will be fully open so that it will allow full flow in the system.
I'm going to explain to you our flow meter, the codes, and how it was calibrated. First, let me show you the codes. These are the codes of our flow meter. So basically, before we can make the codes, we first need to calibrate the flow meter so that we can create our own equations for our flow sensor. So how did we calibrate our flow meter? We calibrated our flow meter by using this type of experiment in which we have a controlled flow and controlled time. Our variable, I'm sorry. We have a controlled volume and a controlled time. Basically, we did 10 trials for each liters per minute. So, for example, in 1 liter, we did 10 trials in which we got the pulse average of the 10 trials, and we did it for the 2 liters, 3 liters, and up to 8 liters. After that, we made a graph to show the equation that we're going to use for the flow sensor, which is here. As you can see here, this is the graph of the equations for our flow sensor. After that, I'm going to explain to you now the DS18B20. The codes for the DS18B20 has limited capabilities, meaning that we almost cannot change parts of its code since it is a digital sensor. So basically, our calibration, it will not also include our calibration since it is all of its parts are already built in its components, and so that the code cannot be changed and will be retained by the Arduino makers. Next is our quadra and our servo motor. Basically, our servo motor is connected to the quadra. The quadra changes dependent on the servo motor changes angles dependent on the amount of temperature. If the temperature is above 80 degrees, then the flow is at maximum. But if the temperature is below 80 degrees, then the flow is at minimum. That is the code for our servo motor, which I'm going to show you. Our code for the servo motor is also our code for the DS18B20, since they are correlated. Okay, and then that's all. Okay, thank you very much for listening.
Since we cannot operate the steam generator due to electrical problems, we will use this light bulb to measure our temperature.
Now we are going to use the light bulb as a heat source. And we used DS18 sensor to determine the temperature. And we have set the temperature 80 degrees Celsius, and once the temperature reaches 80 degrees Celsius, the servo motor will change its angle, and the next procedure my colleague will explain.
Since the servo motor is connected to the quadrock, right there, once the servo motor changes its position, the quadrock also changes its output. The quadrock is connected to the pump. Once the quadrock changes its output, the pump also changes its output.
The output of the pump has only two variables, 42 and 43. At maximum, it is 43 liters per minute, and at minimum, it is 42 liters per minute. If the temperature reaches 80 degrees, its flow reaches also 43 liters per minute. If it reaches below 80 degrees, then it also reaches the 42 liters per minute.
That's our instrument and system works. I'm Brian Patrick P. Balin.
I'm Luis Jacob P. Bolaños.
I'm Matthias Lawrence Lim.
And I'm Tristan Jeremy Irialina, the cameraman.
And we are Team HTM.
Thank you.